Okay, example 2 says Asan loves a Ferris wheel. The Ferris wheel at the town fair is 30 meters tall and makes one rotation every 40 seconds. So, so far I know a couple of things. First of all, I drew a little Ferris wheel down here. So I just drew a circle. And what I know about this so far is that it's 30 meters tall from top to bottom. So that's 30 meters. And that the Ferris wheel makes one rotation, so from bottom all the way around, back to the bottom in 40 seconds. So what this actually tells me is the length of one cycle or one rotation on the Ferris wheel. So this is actually the period of the function. It takes 40 seconds for one rotation to happen. Okay. In part A, it says complete the table of values showing Asan's height above the loading platform at different times. Assume a constant velocity and that the time begins when he boards the Ferris wheel. Okay, so let's say he boards the Ferris wheel at the very, very bottom that we have here. So what that means is initially his height above the loading platform is 0 meters. Okay, because every 40 seconds he ends up back in the same place, then that means in 40 seconds his height above the loading platform would be 0 again. And then in another 40 seconds, so at 80 seconds, it'll be back here. And then at 120 seconds, he'll be back to where he started as well. Okay, so that's what that tells me so far. Now, the values that I've chosen here for the time, I've chosen them specifically so that I look at halfway through one cycle, a quarter of the way through one cycle, and then 3/4 of the way through one cycle or one rotation on the Ferris wheel. So halfway through his rotation on the Ferris wheel, he ends up at the very, very top, which means his height above the ground halfway through one rotation is 30 meters. So I know that at 20 seconds, his height above the ground is going to be 30 meters. So what that means is every 40 seconds, he's going to end up in the same place again. So in 40 seconds, his height's going to be 30 meters again. So what that means is halfway through the second rotation, this height is also 30 meters. And halfway through the last rotation, his height again is 30 meters. Now what we're going to look at is what happens 1/4 of the way through one cycle and 3/4 of the way through a cycle. So 1/4 of the way through the cycle he's here, and 3/4 of the way through the cycle he is here. Now at those 2 points we need to figure out what his height above the ground is going to be. And if you actually notice, this is the distance from the center down to the bottom of the circle. And what that distance also represents is the radius of the circle. So if the diameter is 30, that means that the radius must be 15. So 1/4 of the way and 3/4 of the way through one rotation, he's actually 15 meters above the ground. So at 10 seconds, he'll be at 15 meters. And at 30 seconds, he'll be at 15 meters again. So this is how it works. He's at the bottom of the Ferris wheel. His height above the loading platform is 0. 10 seconds later, he's at 15 meters. 20 seconds later, he's at 30 meters. 30 seconds later, he's at 15 meters. And then at 40 seconds again, he's at the bottom because it's been one rotation. Now, this pattern keeps repeating every 10 seconds. He's going to be back to the previous spot that he was. So at 50 seconds, he's at 15 meters, 70, 90, and 110. It's all 15 meters from there. In part B, it asks us to graph the data from the table of values. So I'm going to have time in seconds along the bottom. And I'll label the axis here T. And I'll have height above the loading platform along the vertical axis. So this is height above loading platform in meters. And I'll put H at the top to represent height. So I need to make sure my time values go up to 120 seconds. So I'm going to probably use a scale of tens. So that's 10. This would be 20, 40, 60, 60, 70, 80, 90, 100, 110, and then 120. And then my vertical axis, I need the heights to go up to about 30. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So maybe I'll use a scale of 3s. So that would be 3, 6, 9, 12, 15, 18, 21, 24, and then 27 and 30. Okay, so if I plot my points, I have a point at 0 and 15. 0 and 0, sorry. So 0 and 0 starting with my first point. So I'm just plotting the points from my table of values. And sorry, I know you won't be able to see both of them at the same time. But my first point is at 0 and 0. My second point is at 10 and 15. Then I have a point at 20 and 30. And then 30 and 15. And then 0 and 40. Okay? And this pattern sort of shows you how Asan's height is changing while he's on the Ferris wheel. And what you'll notice is that it increases and then it decreases. And this is going to continue to repeat for 2 more rotations. So he's up to the maximum, then he goes back down to the minimum. Then he goes back up to the max, and then back down to the minimum. Now, what I want you to recognize is, I know it might be tempting to try to draw zigzags here, so pointy zigzags. However, if you actually look at how his height is changing while he's on a Ferris wheel, initially his height changes very slowly, but as he starts to get to the sides, his height starts to change really fast. Okay? And then as he continues, his height's changing really fast, but then the change in height ends up being slow. Slow change in height, fast change in height. Fast change in height, slow change in height. Okay? So what you need to recognize is that the graph is not linear because it's a varying change in height. And so what that means is when you're sketching your curve, when you're sketching your graph, it's actually a bunch of curves. So it curves upwards, and then he changes height slowly, and then he changes height fast, changes height slowly to get back to the bottom of the Ferris wheel. Changes height fast, slow, fast, slow, slow, fast, fast. So slow, fast, and then slow again. So it ends up looking like a curve. And if you notice, this is actually a periodic function because you'll notice that it's a pattern that repeats itself every 40 seconds. Okay? So before we answer the remaining questions, what I want you to think about is the period and the amplitude. So we already talked about the period here being 40 seconds, since that's how long it takes for one rotation on the Ferris wheel, and that's how long it takes for one cycle in the graph. And if you think about the amplitude, the height of the graph here between the minimum and maximum is 30 meters, and half of that, if you're calculating the amplitude, would be 15 meters. And what does that actually represent? Well, where else did we see 15 meters? Oh yeah, on the Ferris wheel, the actual radius of the Ferris wheel is 15 meters. And so that'll always end up being true when you are looking at the amplitude and you have a Ferris wheel type of question. The amplitude always ends up being the radius of the Ferris wheel. Alright, so last couple of questions in part C, and we will be using the graph that we have here to help us answer these questions. In part C it says, find Asan's height after 18 seconds. So we're told the we're told the time, and we're looking for the height. So here's our value for T, and we're looking for the value of H. Okay? And so if we look at our graph, we should be able to identify that. We want to know at a time of 18 seconds, what is his height? So that's 10, that's 20, 18 seconds is about here. So I guess you can approximate that his height would be about 29 meters. So what this means is the height at 18 seconds is about 29. And if I write this as a sentence, so I would say, therefore, his height would be about 29 meters at a time of 18 seconds. And this sort of makes sense, and you can always check to make sure that your answer is reasonable. If you actually look at the Ferris wheel, Remember what we talked about when we were looking at the Ferris wheel? This is 0. This is 10 seconds. This is 20 seconds. At 20 seconds, he's at about 30 meters. And 18 seconds is just before that. So he's at about 29 meters above the ground. So that answer does make sense. For part D, the last part says, determine when Aeson first reaches a height of 10 meters. Now, the reason why the question is saying first reaches a height of 10 meters is because he actually reaches a height of 10 meters several times while he's on this Ferris wheel. So we want to know when he first reaches a height of 10 meters. So let's look back at our graph. And the first time he reaches a height of 10 meters, so this is 6, that's 9, 10 is about here. The first time he reaches a height of 10 meters is just before the 10-second mark. So this is at 10 seconds. So just before the 10-second mark, he reaches a height of 10 meters. So I guess we can say at around 8 seconds. Okay, so therefore, Aeson first reaches a height of 10 meters at about 8 seconds. And again, you can check your work. And if we look at the graph, we already know that's 8 seconds. If we look at the image here, 10 meters is about here. And so it would take about 8 seconds since it takes 10 seconds to get to that point there. Now, you could figure out when else he would be going up the Ferris wheel and would still be at a height of 10 meters. And you know that it's going to be every 40 seconds that that's going to happen. So every 40 seconds, he'll end up at the exact same point that he was previously. Okay? And that point would be right here on the Ferris wheel. Okay? So these points here